Hello everyone, welcome to Chemex channel. This is Elvis. I'm the sales engineer at Chemex Machinery. And right now, I'm here at our factory. Next to me is a newly finished edible oil refining equipment with a daily capacity of 5 tons. It has a single tank capacity of 2.5 tons per batch and can process 2 batches in a day, easily hitting that 5-ton daily output. The core of this whole setup is 4 tanks, each with its own unique function. The first one handles degumming, the second one for deacidification, the third one for dehydration and bleaching, and the fourth one is for deodorization. This standardized process guarantees great refining results. After going through this 4 tanks oil refining process, the phenol oil can easily meet Grade 1 oil standards. What's more, this equipment is super flexible. It works for over 95% of edible oils on the market, like peanut oil, soybean oil, rapeseed oil, sesame oil, and more. For equipment with a daily capacity of over 2 tons, we all equip them with a thermal oil heating system. This not only controls the processing temperature stably, but also cuts energy cost a lot compared to traditional electric heating, saving customers money on long-term operation. And the key part of this system, the thermal oil boiler, can use different fuels based on local resources available to the customer. Whether it's gas, diesel, coal, firewood, or even biomass pellets, it can adapt to them all, making it really practical. Besides the core refining tanks, the equipment also comes with supporting equipment like steam generator, a leaf filter, a crude oil tank, a circulating cooling water pump, vacuum pump, and a complete thermal oil system, forming a full production plant. At Chemex, we can customize equipment with different capacity for you. We also do both chemical refining and physical refining process. If you have any needs related to the edible oil refining, feel free to contact us at any time. Next, let's follow my camera and take a closer look at the details of this equipment. Thank you very much.
First of all, pump the crude oil through the pipeline into the first refining tank using an oil pump. Usually in the refining equipment, oil goes in through the top of the tank and comes out from the bottom. The first one is an open top tank, and we use it for degumming. Once the crude oil's pumped into the first tank, we generally heat it up to 60 to 80 degrees Celsius. Then add some brine of a certain concentration. Make sure the brine's temperature is about 5 to 10 degrees higher than oil's. Stir the brine and crude oil quickly for 20 to 30 minutes. Then stop stirring and let the oil sit and settle. After a while, the gums, water, and impurities will sink to the bottom of the tank. We can drain the impurities out using a manual valve, and that's how degumming gets done. After that, use the oil pump again to send the degummed crude oil through the pipeline into the second refining tank. The degummed oil goes into the second refining tank. It's an open tank too. This is where we do the deacidification step. Same as before, we need to heat the oil up to 60 to 80 Celsius degree first. Then add some alkaline solution of a certain concentration. And the alkaline solution's temperature should be 5 to 10 Celsius degree higher than oil. Just like earlier, stir them quickly for 20 to 30 minutes so the alkaline solution fully reacts with the free fatty acids in the oil to make soap stock. Once the soap stock forms, let the oil sit and settle like we did before. The soap stock, water, and impurities will sink to the bottom of the tank, and we will drain them out with a menu valve. That's how deacidification gets done. After that, the deacidified oil is pumped into the third tank using the oil palm again. The third tank is dehydration and decolorization tank, also known as vacuum stirring tank. This tank adopts a double coil design. One is a thermal oil coil for heating, and the other for cooling. This design enhances work efficiency, enabling rapid temperature reduction, and both dehydration and decolorization processes are completed here. Dehydration step: heat oil to 95 to 105 Celsius degree. The moisture in the oil will boil and turn into water vapor. Second, the water vapor is directly pumped out of the tank by a vacuum pump, thus achieving dehydration. Third, the completion of dehydration can be determined by observing the water mist condition on the tank's watch window. Decolorization step. After dehydration, the decolorizing agent, usually bleaching clay or activate carbon, is sucked into the tank through a pipeline. Second, the decolorizing agent is fully stirred and mixed with oil, absorbing the pigments in the oil to achieve decolorization. The oil after dehydration and decolorization is pumped into a leaf filter via a decolorizing oil pump to filter out the decolorizing agent, and then store in the decolorizing oil tank. Fourth, finally, the oil in the decolorizing oil tank is pumped into the fourth tank through a pipeline. The fourth tank, also a vacuum deodorization tank. That's where we do the deodorization step. It is designed just like the third one. It has a double coil setup, one for heating, the other one for cooling, and a watch window so we can check what's going on with the oil inside anytime. The deodorization step. First, heat the oil up to 220 to 240 Celsius degree, and at the same time, pump hot steam into the tank. The steam mixes fully with the cooking oil. It's like giving the oil a steam bath. Second, with a high temperature, the odor in the oil will escape along with the steam. Then a vacuum pump sucks out all the water vapor that's carrying those odor from the tank. That's how we get the deodorization done. Third, we pick different vacuum pumps depending on the machine type. Small machines use a water circulation vacuum pump. Medium ones use a water jet vacuum pump. And for machines that needs really high vacuum levels, we use a roots vacuum pump. Also, like I said before, the third and fourth tanks work at pretty high temperatures to cool them down fast and make things more efficient. We've got a cooling water circulation system. Here's how it works. A water palm moves water from the tank into the cooling coils, which helps the super hot cooking oil cool down quickly. And the video shows the flow direction of the cooling water in the pipes. After all the refining steps, the final refined oil can be directed to the storage tank through the oil outlet. For oil refining equipment that processes more than 2 tons per day, we usually suggest customers go for the thermal oil heating system. Compared to that, regular electric heating is cheaper for the equipment itself, but electricity cost is way higher when using it. That ends up hurting the overall cost effectiveness of the whole setup. Here's how the thermal oil heating system works. The thermal oil boiler heats up the thermal oil, then the hot oil is pumped through the thermal oil circulating pipes into the heating coils of each tank. That's how we heat the cooking oil. And during this process, the thermal oil and cooking oil are completely separated, so there's no need to worry about any hygiene or safety issues at all. We have different types of thermal oil boilers available, and customers can choose based on their heat source, like oil, gas, wood, coal, biomass, you name it. Diesel or gas boilers, they are usually horizontal type, as shown in the picture and the video. And coal, wood, biomass boilers, these are typical vertical design, as shown in the videos and pictures. All the control and operation of the whole equipment are integrated in this electric control cabinet. Every button and indicator light inside has Chinese and English bilingual labels, so customers can easily understand what each one does. Let me tell you about the key features of this cabinet. Components quality. All electrical components are from top domestic brands, super stable in quality and reliable in performance. Plus, every single component has a label on it, which makes it easy for customers to understand and fix things later on. Internal wiring. The wires inside machine are pre-installed, and they are all national standard pure copper core wires. Each wire is covered with an insulating sleeve for protection. We also use wire management boxers to organize the routine of the internal wires, so everything is neat and orderly, no safety risks at all.